All right, so let's continue with the next applications of Newton laws, which is motion of connected particles. Okay, motions of connected particles. Now, these are two bodies that are connected together. Okay, so now in questions coming out from this part, they will ask you to calculate for. They will either ask you to calculate for the acceleration of this body with which these bodies are moving, or with which these connected bodies are moving. They can also ask you guys to calculate for the tension acting on these masses or on these bodies. Okay. Now, before we start deriving the equations to calculate for the acceleration and their tension, now these are important things you need to know. Okay. Yes. Now, the direction, because this is a pulley. Yeah, this is a pulley. Now, you take note, the direction of the motion of the connected particles. It can either be like this, or it can either be like this. Okay. So the direction depends on what? The direction of the heavier mass. Okay. So in this case, M2 is the heavier mass. So that is why you see something like this. That's why I say that the direction is like this. Okay. And if you understand, the direction is like this. Okay. Yes. Now, these two particles, the important thing to take note of is that one, the direction of motion is determined by the heavier particle. Yes, in this case is M2. Okay, is the heavier one. Yeah. Now, another thing you need to take note of is that both of this body, they move with the same acceleration, and that acceleration is known as common acceleration. They have common acceleration. Okay, so they move with the same acceleration. They have common acceleration. Okay, so that is just it. And the last thing you need to take note of is that the tension acting on M1 and M2 is the same. Okay, one, the direction of the motion of the pathway is determined by the heavier mass. On that one, the number two is that they have common acceleration. Yes, the two particles, they move with the same acceleration. Then the last one, the tension acting on them is the same. They are acted upon by the same tension. Okay. Yes. Now let's continue. Now, in some particular in questions, yes, they will ask you to calculate for what? To either calculate for their common acceleration. They will also ask you to either calculate for what? For their tension. And lastly, they will also ask you to calculate for the total force or the net force acting on what? On this system. Now, before I continue, tension, what is tension? Tension is, when, for example, whenever the mass is attached to a string, or like tension is that force that acts on what? That acts on a rope, that acts on a string, anything that relates to rope. So that is tension. And tension is an upward force. Yes, tension is always an upward force. Tension acts on what? Acts on a rope, or you can say a string. Okay. Yes. Whenever a board is connected by a rope, yes, there is usually tension acting on what? On that rope. And take note, that tension is always what? Is always an upward. Is always an upward force. Okay. So that is just it. Now, remember the acceleration, both of them have the same acceleration, which is known as common acceleration. Okay. Now let's derive the equation with which we can solve questions. Let's derive the equation for common acceleration. Now, there are some important things you need to know. Remember, I told you guys that whenever an object is moving upward, the in this case, moving upward is always usually positive, right? Then moving downward is what? Usually negative, right? Now, I told you guys that the motion in this scenario, the motion of this particle is like this, right? Is like this, from like this, right? Yes. Now, if you look at this side, this part, let's say this part is moving upward. Yes, this part is moving upward. While this other part is what? Is moving downward. I don't even understand. You can see it from the acceleration moving upward. This other side moving downward. Okay. So let's continue. This side moving upward, the acceleration is what? The acceleration is positive because why? Going upward is positive. While this side, this side moving downward, the acceleration is what? Is usually negative. Okay. Now let's do something now. Now, in order for us to derive the equation for the common acceleration and the tension and all. We divide it into two parts. We calculate for the total force acting on this side, and we also calculate for the total force acting on this side. Okay. Now, if you look at here, how many force is acting on M1? There are what? Two force. One is the tension. The other one is what? Is the weight. What about M2? There's also two force. The tension and the weight. Okay. So total force TF, T sub square F, total force acting on M1 is equals to what? The tension. Tension is going upward, right? Remember, going up is positive. Then minus what? W1, which is the weight. Weight is always going downward, right? Now let's go to this side. The total force acting here is equals to what? Is equals to the tension as well. Then minus what? Minus the weight M2. Okay. Now let's continue. Now, what is formula for total force? Or rather, what is formula for force? Formula for force is what? MA, right? Yes. Since we are using this guy, we will to be what? M1A, right? Equals to what? Tension minus what? Minus W1. Now, the acceleration here. The reason why you see that the acceleration is positive here is because why? This side is usually a upward motion because the acceleration is moving upward. Yeah, so this is why it's what? It's positive. Okay, here is positive. The acceleration here is positive. Okay, so that is just it. Now this side, total force will be what? Is equals to M2 bracket open minus A bracket close equals to tension minus what? W2. The reason why acceleration here is negative is because why? This side, the motion of this side is going downward. As it is going downward, that one is always negative, right? So M2 times minus A will give us what? Give us I'm coming. Give us minus M2A. Okay? Yes. This side is negative. You find out that this side is not negative, this side is positive because of what? Because of the acceleration, right? Now let's continue. Now, we want to make tension stand alone. Making tension stand alone, we take what? The weight to this side, right? If the weights come to this side, to turn to what? To turn to positive, right? So everything will now be what? Everything will now be M1A plus W1 is equals to what? Tension, right? Now, where is W1? Wait, W1 is equals to what? M1G, right? Weight is equals to mg, right? Based on the fact that we are regarding to this m1, so that's why you see m1 here. Okay, weight w1 is equals to m1g. Okay, so in the place of this one, I remove this w1 and put what? I put m1g. Okay, m1g. Okay, so tension here is equals to what? M1a plus what? M1g. Now worry about this side. Now this side, if we want to make the tension as what we did here, we also did here. We want to make the tension stand alone. So minus W2 will come to this side. If you come to this side, you turn what? You turn positive, right? So everything will now be what? Everything will now be W2. Oh my god, I'm coming. Everything will now be what? W. Coming use this other marker. Everything will now be what? W2. Because W2 will turn to positive, right? Then minus M2A is equals to what? Tension, okay? So that is just it. Now, we have gotten the tension in this side, acting on this side. We have gotten the tension acting on this side. Now, what did I tell you guys? Tell you guys that in motion of connected particles, their tensions are the same. Tension acting on this one and this one is the same, right? Tension here is the same with tension here, right? So, since the tension are equal, we can okay, let's just continue. Since the tension, let me clean this part. Okay, yes, let me clean here. Okay, so since tension in M1 is equal to tension in M2, now what is tension? The tension acting on M1 is what? Is M1A plus M1G. So it now be what? M1A plus what? M1G is equals to, what about tension acting on what? On M2. Tension acting on M2 is what? Okay, before that, let me turn this W2 to what? To remember, the weight is what? M2G, right? Mg. As regard to this M2, that's why you see M2 here. M2G, right? So in place of W2, we'll put what? We'll put M2G. M2G. Okay, so the tension in M2 is what? Is equals to what? Is equals to M2G minus M2A, right? So that be M2G minus M2A. Okay? Yes. So what are we going to do next? Now, what are we going to do next? Since we are looking for the common acceleration, we want to get the common acceleration. We will take the mass that has acceleration to one side, and we'll take the mass that have g to one side, to the other side. I don't know if you understand. Now let's take, we want to take the mass that has g, that has a to this side. We want to take the mass that have g to the other side. Okay, so we want to take this one to this side. So now be what m1a, if this one cross over, it will be plus what m2a, then equals to m2g. If this one cross this side, to be what minus m1g, right? If plus m1g cross the other side, what minus m1g, right? Yes. Now if you look at these two parts, there's something that is common here. This is a. If you look at these two parts, there's something that's common there. It's what is g, right? So the things that is what is common here is what is a, right? So we bring out a bracket open, m1 plus what m2, right? Because why m1 a times m1 will give us m1a, a times m2 give us what m2a. So it's the same thing. Okay, same goes for here. The g is what g is common here. So we bring out g, then bracket open m2 minus what m1, right? So that is just it. Now we are looking for what a. We want to make a stand alone. We divide both sides by what m1. We divide both sides by what m1 plus m2. Okay, m1 plus m2. This one we cancel. Okay, we will arrive with something like this. We will arrive with what? We will arrive with a will not be what? A will not be equals to what? G bracket open m2 minus m1 all over what m1 plus m2. So this is it. Okay, so this is g can be here or g can also be here, so it's the same thing. Okay, so this is the formula to calculate for what? To calculate for the common acceleration in motion connected by of connected particles. Okay, so it's very easy. You can cram it or you can just learn how to derive it. It's just easy. Just make sure that the acceleration is positive, the acceleration is negative. Then you know the way I did it. For the total for certain year, and all. Okay, so this is the formula to calculate for what the common. This is because this is an exam based question. They ask it a lot in exam. Okay, they ask you to calculate for common acceleration. So this is the formula to calculate for what the common acceleration. Okay, now what about the tension? They also ask you to calculate for tension. We have already gotten our tension since. Remember, one of the tension is equals to what? Tension acting on M1 is what? M1A plus what? M1G. Tension acting on what? On M2 is equals to what? M2G minus what? M2A, right? So that is just it, okay? So if they ask in a particular question, they will ask you to calculate for the tension acting on this system. Just know if they give you the common acceleration, if they didn't give you common acceleration, you will first look for the common acceleration first. Once you get the common acceleration, then you can use your common acceleration, then the mass and g to get what tension. Okay, now just take note, since the tension are equal, are the same, you can use any of these two formulas to get the tension. You can use the second one, you can use this first one, so any one of them you can use to get the tension, because the tension acting here is the same thing, is equal to the tension acting here, they are the same. Okay, so this is the formula to calculate for what? To calculate for the common acceleration, while either of this one, any of them, is this other formula, any of them you can use to calculate for what? The tension acting on the system. Just as long as you know their common acceleration. And where is their common acceleration? This is their common acceleration. Okay. Then the last thing under motion of connected particle is that the total force acting on the system, the net force or the total force, the net force acting on the system is equal to what? 2 of the tension. Okay. Yes, 2 tension, 2T. Okay. Yes. So once for if that's now, for example, calculate for the total force acting on the system is very easy. Just first look for what? Look for it. Use any of this one to get the tension. Okay. Once you get the tension, multiply it by 2. You will get the total force acting on the system. Okay. So take note. This is the common formula for common acceleration. This is the formula to calculate for what? For the tensions. Then what is the formula to calculate for the net force? Okay. So now let's do calculation question on motion of connected particles. And before we move towards block and cord system, also known as a track glider. All right, so let's do some calculation question under motion of connected particles. Okay. Now, if you look at the question on the board, they said Two bodies of masses 5 kg and 8 kg are connected by a light string passing over a smooth pulley. Okay, they say find their common acceleration, the tension in the string, as well as the force on what, on the pulley. How are you going to know that this question is coming from motion of connected particle? If you just read it, you find out that they said two masses 5 kg and 8 kg are what, connected by a string. Yes, by a light string passing over a smooth pulley. So this is how you know that, oh, this question is coming from where? From motions of connected from motions of connected particles. Okay, so they are asking us to calculate for what? For their common acceleration. Okay, and I gave you guys the formula. Now, what is the formula to calculate for what? The common acceleration of motions of connected particles. The formula to calculate for the common acceleration is A is equals to bracket open m2 minus m1 bracket close g all over what? M1 plus what? M2. Okay, so now, the very first mass in the question is the M1, while the second mass is what? Is the M2. This is the first mass mentioned in the question. This is the second mass. So this one is M1, while this one will be what? M2. So our M2 is what? 8. Okay, to be 8 minus M1 is 5. Then and G is what? G is 9.8, or we can use 10. Okay, let's use 10. Okay, times 10. Then divide by what? M1 is 5, M2 is what? 8. Okay, so 8 minus 3 will give us, 8 minus 5 will give us 3. 3 times 10 will give us 30, right? Then divide by what? 5 plus 8 will give us 13, right? So let's divide it. Okay, so 30 going to 13 will come in. 30 going to 13 will give us 2.3. Okay, so their common acceleration is what? Is 2.3, right? Meter per second square. So you can see that it's very easy. Okay, just on the formula, understand the question, you can solve. Okay, the next thing they're asking us to do is to calculate for the tension, and I gave you guys the formula as well. I told you guys that the tension can either be what? And the tension can either be, I'm coming, m1a plus, let me just derive it. Okay, let me just derive it fast. Okay, so I'm coming tension. Okay, another tension, then m1, then m2. Okay, so the total force acting here is what? Is tension minus tension, then minus what? The weight. Okay, so if you want to make tension stand alone, the weight to come over here, right? So total force will be what? M plus W equals to what? Tension, right? And total force is what? Is MA. Then plus weight is what? Mg equals to tension. Since we are using M1, I'll put 1 here. So tension is equals to what? M1A plus M1G. Or tension in this other side, the tension is equals to what? In the other side is equals to M2G minus what? M2A, right? Yes, okay, because I've cleaned it before. So you can use any of these ones. If we use any of them, we'll still arrive at our answer. Okay, so let's do it. Let's use any of them. You see that we arrive at the same answer. That should tell you that the tension acting on M1 and M2 are equal. Okay, so we know our acceleration to be was 2.3. Then let's look for the tension. Okay, let's use this one first. So our M1 is what? 5, right? Is 5. Then times acceleration is what? 2.3. The bracket close plus M1 is still 5. Then times what? 10 equals to T. 5 times 10 will give us 50. Okay, then plus 5 times 2.3. 5 times 2.3 will give us 11.5. So 11.5 plus 50. 11.5 11.5 plus 50 will give us 61.5 Newton. Remember, tension is a force, right? So that's why I put Newton here. So this is the tension acting on these masses. Now let's use this other one if we arrive at the same answer. Okay, so let's do it. Coming. All right, so M2 is what? M2 is 8. So times what? Times 10. G is 9 is 10. Then minus M2 is 8 again. Then times what? A is what? 2.3, right? 2.3. So let's do it. 8 times 10 will give us 80. Then minus what? 8 times 2.3 will give us what? 8 times 2.3. 8 times 2.3 will give us 18.4. 18.4. So let's subtract it and see if we arrive at 1.5. So 80 minus 18.4 will give us what? Will give us 61.6. Okay, so let's say that we are correct. Okay, 61.6 Newton. So it's correct. It's correct. So if you approximate this will be 62 Newton. If you approximate this will be 62 Newton. So that's to tell you that the tension on both sides are equal. Yes, the tension acting on both masses are always the same, are always equal. Now, what about the force? The force, that is the total force on the pulley. I told you guys that the total force acting on the pulley, the net force, the total force or the net force is equals to what? Two of the tension, right? Two tension. So our tension is what? 61.5, right? So 2 times what? 61.5. Okay, so if we multiply it, we will get what our total force. So 2 times 61.5 will give us 123. So the total force acting on the pulley is what? 123 Newton. So that is just it. This is saying that it's very motions of connected particles is very easy. Okay, and the question is rampant in the exam. Okay, so how can you calculate for the total force? Just now I told you guys the total force or the net force is equals to 2 of what? The tension, right? So it will be 2 times our tension, 2 times 61.5 or 2 times 61.6. We arrive at what? 123 Newton. So that is it. Okay, now let's move to the next applications of Newton law, which is block and cord system, also called air track glider.